Hello everybody, let's look at some more micro models. So these models particularly refer to the kinds of activities we could do in a lesson to encourage learning. So there's an umbrella of techniques which are called active learning. Things like think, pair, share, the pause procedure, fact rounding, network phasing, learning cells, active writing, and team quizzes. So think, pair, share is a general approach to activities rather than anything specific. Think, pair, share means in the class I say to the students, think about this for yourself for a minute, then discuss it in a pair, and then share it with the larger group or share it with the whole class. So it's a good way of giving students individual reflection time, negotiating that reflection with an individual, and then negotiating it with the whole group. So an example of it could be doing the pause procedure. So after, 15 to 20 minutes, students stop listening to what you're saying. So something that can be effective is just to pause and say, all right, spend a minute writing down the 3 most important things you think we've learned in the last 20 minutes. Get them to write it down, and then maybe even do a think, pair, share, and get them to share the top 3 things they think with their classmate beside them and see if different people are picking up different things. But it's a good idea every 20 minutes just to give it a pause anyway. And here's a list of a few different things we could do: a 1-minute paper, top 3 things, review notes and put question marks beside ideas you have difficulty with. What's the least thing you understand about today's class? Lots of stuff like that. Fact rounding is a technique that's used at the end of a lesson, where you ask each student, one after the other, one fact, one word, one idea, one topic that was discussed in class, and then the next student can't mention that one. So by the time everybody said something, generally you've covered the entire class and you've revised it just in a few seconds. Network phasing is if you've got a topic that breaks down well into stages to create small groups of students to work on individual bits of it, then to have another phase where bigger groups of students bring together the output of the smaller number of students group work into larger chunks of material, and then maybe another phase where the whole class comes together and brings together everything of the larger groups work into a single piece of content. A learning cell is where students talk about questions, and either one student is the asker or the answerer of the question. And similarly, you can do it in groups or in pairs. It can be very effective in terms of drawing out a student's understanding of what's going on and having a proper discussion. It's very much like the idea of extreme programming in computer science. Active writing, where students are asked to submit a question about what's been covered in the material for the next class. And this is very effective because then you bridge the gap between each lesson by having questions from the last one. I think this is a very effective technique. Divide the class in half and get what I call them Group A and Group B, and Group A has to write 20 questions for Group B, and Group B has to write 20 questions for Group A about the topics covered on the course. I think it's really handy for the last lecture of a particular session, just to get them to study the material carefully and think of tricky questions for each other. And it can be highly motivating and things like that. Edward de Bono has developed a model of how to do meetings in corporations called the 6 Thinking Hats, which I personally have adopted with his permission to a model of instructional design. The 6 Thinking Hats, each hat represents a different phase in the meeting. The blue hat is the overview hat, the white hat is the facts and figures, the green hat is the creative part of the meeting, the yellow hat is looking at the positives of an idea, the red hat is the emotional phase, and the black hat is looking at what concerns or worries about a particular topic. So I've developed a model of instructional design that just says all of these phases should be represented in a lesson. We should have an overview at the start explaining what the topic is about, blue hat, and finish with the blue hat as well. We should have a phase where we're explaining to students the information but we should also give our opinion in the red hat mode. The white hat is the facts, the red hat is our opinion. We should also look at the benefits and weaknesses of an idea, the yellow hat and the black hat. We should also have time to be green hat as well, thinking about the interesting and getting the students to do interesting activities. So that's a version of the instructional design model I've created, again, with Edward de Bono's permission, that's been used in a number of primary schools, secondary schools, and third level institutes, both in Ireland and in other countries. So overview, facts and figures about a particular topic, the positives about a topic, perhaps the negatives, some interesting activities we could do around the topic, my opinion as the teacher about the topic, a review of facts, and then a summary. Other micromodels that are worth mentioning briefly are learning by teaching, problem-based learning, project-based learning, inquiry-based learning, action learning, progressive inquiry, and service learning, or community-based learning, that's also called. So lots of other techniques out there. Things always to think about from my mind and worth looking up for you are Miller's magic number, Dunbar's number, Arrow's impossibility theorem, attention economy, bounce rate, anticipated reciprocity, legitimate peripheral participation, and behavioral targeting. I mentioned it in class today, so we looked at Gagne's ideas, or John Hattie's rather, idea of what activities help student achievement, and we saw that feedback, instructional quality, and direct instruction are three things that the lecturer does that are very important, and the students' prior cognitive ability and their disposition to learn are important as well, but there's so much a teacher can do. And that's from John Hattie's paper, What Teachers Make a Difference, What is Research Evidence? So finally, I'll mention there was an article in The Economist over the summer about what makes a good teacher. It was really based on Elizabeth Green's book. It's called Building a Better Teacher, focusing on looking at excellent teachers and what do they have in common. Surprise, surprise, the real thing good teaching, good content delivery, good instructional design is built on is hard work. I'm afraid that's it. In Green's book and in The Economist article, they just make the point that people who are willing to do trial and error, to experiment with different approaches, different techniques, different technologies, different lessons, are the most successful teachers. There isn't an answer. I think these models are excellent in terms of telling us ideas, approaches, directions, but nonetheless, there isn't you're not going to find a model that says, well, if we follow this, everything is going to be fine, there'll never be a problem. That is not the case. What is the case is, though, if we evolve and grow and allow ourselves to learn new technologies and new models, new techniques, the more we work at it, the better we will be as teachers, the better we will be as instructional designers. So it's all about recognizing an incremental improvement, incremental growth of you and of the students. So it's not about one size fits all modeling. Thanks very much. Thanks for your attention.